You can start.
Good morning, viewers. We are back again on our tutorials, but I'm sorry actually that it's coming late today. Yesterday being Monday, we would have held our lesson, but some deficiencies surrounded it a lot. So that's why I apologize. So today we'll be going to number concepts. Last time we did whole numbers. It's still a link to this, but this will help you to introduce it better. So let's proceed. You hear number concept. It's just all about the common understanding we can have in a number. Now, let's begin by saying that a number is a natural phenomenon. When I mean a natural phenomenon, it's a natural phenomenon. It cannot be seen or touched. Now, for example, you can say we have 10 students in a classroom. We have 10 students in a classroom. 10 students in a classroom. Now, this 10 cannot be seen or touched. Rather, it is used to show the number of students in a classroom. That is why we have numerals. That's what we know as numerals. Numerals. Now, numerals are used to represent number. Numerals, you can say that numerals are used to represent number. That's why we have different people that uses different ways of, their numerals. For example, the Romans uses their numerals like this: I, V, VI, IX, and X. These are the Roman numerals. They use this we are seeing to represent their own number. But we have the one we use generally in the world of today, like this: 1, 2, 3, 4, 5, and so on. This is Hindu form. It is derived from the Hindu form. Actually, this number, when you see numbers like this, it's called numbers in base 10. So it was derived from the Hindu form. This is the Hindu way of counting, which we have also adopted as a general way of counting today. So that is it. So we'll be going into number sets. Number sets. Now we have in number sets we have a whole number, which can also be known as a counting number. We also have, let me write them down. The whole numbers or counting numbers. We have the whole number and the counting numbers. We have the rational numbers. We have the irrational numbers. And so forth. Let's just establish on these three. The whole numbers. When we talk about whole numbers, I've established that whole numbers are integers. Which integers can simply mean positive or negative numbers. Where you can have your -3, -2, 0, 1, 2, 3, and so on. These are whole numbers. It can be a negative or a positive number. You can have also rational numbers. When you talk about rational numbers are fractional numbers. Like for example, we have an example like P over Q. They are fractional numbers. Now P over Q is a typical example of a rational numbers. And also rational numbers can be a whole number. Let me show you. For example, if I have 4 over 2. Now if I degrade these numbers to its lowest term, you see that I will still have 2. Because 2 into 4 will give us what? 2. So this 2 is a whole number. So you can also say that rational numbers can be what? Whole numbers, because as it is now, this is a fraction. Now if I divide 4 by 2, I'm still going to have 2, which is still a whole number. So that is it. And we also have irrational numbers. And when you talk about irrational numbers are numbers and non-rational numbers. That is to say, you can say that they are numbers that cannot be expressed by the quotient of each integer. You may ask, what is a quotient? Quotient is simply the result derived from when a number is being divided. For example, 4 over 2, that is 4 divided by 2, we have 2. So 2 is the quotient of this fraction. So you can say that irrational numbers are numbers that cannot be expressed as a quotient of an integer. That means you cannot say it is what I got from dividing a particular number with another. Look at what I mean. For example, rational numbers can be something like this. Now, this symbol is also known as square root, but you can still call it surd. So in this case, let's call it surd, surd 2, surd 3, surd 5, and the rest of them. Now you can call this thing an irrational number because there is no fractional number that when it is divided through, you have this answer. So that is why they are called irrational numbers. We also have directed numbers. We also have directed numbers. Directed numbers. Now, when you hear directed numbers are numbers that have sense. They are numbers that have senses. You may ask, is this a psychological sense? No. In this case, it's not a psychological sense, but it is a direct sense. For example, in a number, this will introduce us to number line or number scales. For those mathematics students, you may know what is a number line. We have it like this. Number line has arrow which indicate the direction of a number or the direction at which a number can be extended to, which we have the 0 as the origin. We usually have the 0 as the origin. Now from the origin rightwards, we have the positive number 1, 2, 3, 4, and so forth. And from the origin leftwards, we have the negative number -1, -2, -3, -4. Now, look at this. -4, -3, -2, -1, 0, 1, 2, 3, 4. This is a typical example of directed numbers because the sign will always help you to know the value of the number. That is why it is called directed number. Like I said, it's a number that has sense. That means it is a number that is directed. Now when you now see 1, 2, 3, 4, you should just know it's positive numbers. It must not have a plus sign before you know it's a positive number. But when you see a natural number as this, know it is a positive number. And also when you see numbers that has minus sign attached before them are known as negative numbers. So these are a typical example of directed numbers. Now the summary. Let's just use this for a simple arithmetic like addition. Let's use it to do addition. For example, when I have this, let me have my number line again, where I have my origin 1, 2, 3, 4, and I have -1, -2, -3, -4. Now see, if you are given a equation 1 plus 2, 1 plus 2. Now from our number line, go and take 1. It is now -1 plus 2. So if it's -1, we'll trace it from here. But here it is 1 plus 2. So we go from here. Now we move forward because the 2 is also positive. So we count how many times? Twice. 1, 2. Now what is our answer there? We got 3. So that means 1 plus 2 is equals to 3. You can also see that number line can also help us in a simple arithmetic like addition and subtraction. So though we're still going to come on this lesson full time, that is the number line. Thank you so much for this lesson. Our next class will be on mathematics, will be on place value. Place value. So you know the value or the number sequences we have. Thank you so much. And our next class will be on English. It will be an amazing class, and expect that by tomorrow. I know most of you might be asking or wondering. We have been learning math all the time. Actually, we are going to have English this time. Tomorrow, expect it so great. Thank you so much. Remember that this is the Victor's tutorials lesson. Thank you so much.